Buongiorno Venezia, ciao tutti. I can understand Italian pretty well since I'm Brazilian. I live in France. I speak Spanish, and I have this joke where I often say, well, I'm Brazilian, so Portuguese is my mother tongue. Spanish, it's like Spanish for you, like it's very, very close, so it's pretty easy to learn. I think Italians speak Spanish, or at least understand really well. So, and I have a lot of Latin American friends, so I can speak pretty good Spanish. I have a very, someone that can testify for that, a Colombian speaker that is going to be talking afterwards. We talked a little bit in Spanish just before, sorry. And I live in France, so I speak French. And so, like you have, I say the joke is that I have you have three Latin language, and you get one for free. So I get French, Spanish, Portuguese, then I get Italian for free, because basically everything in your language either is coming from Portuguese or from French or from Spanish. So yes, but I cannot speak that well, but I really enjoy your country. It's been so long since I've been to Italy. Of course, as a Latin American, I love Italy. So I'm really, all of that to say that I'm really happy to be here with you today. Today we're going to be talking about, I can maybe move away this. Oh, why did I start doing this? Like this, I think, because yes, this is better. We're going to be talking about mobile technologies. So this is a comparison of the main technologies that you can use to develop for mobile. So as I was saying, my name is Elaine. Didn't tell you my name yet. So my name is Elaine, and I'm based in France, in Paris, where I work with mobile technologies, as you can guess. And I work at SFEIR, is a consultancy. So I've been doing a lot of native, a lot of iOS, and Flutter as well for the past few years. And so I have a lot of things to share with you today. So a little introduction first, a disclaimer. As I said, I come from native. I've been doing mobile development for more than 10 years. I come from native Android specifically. I did some iOS at the beginning as well. I have extensive experience with native. I love native development, either Android or iOS. I think it's brilliant. And as I said, I have some experience with Flutter as well, which I really like, really enjoy. I'm a GDE, a Google Developer Expert for Flutter. So just have that in mind. Those are my personal preferences. So maybe I know more stuff about that. Maybe I have some bias, but I'll try to be as neutral as I can to talk about other technologies as well. And it is impossible. I only have 40 minutes. It is impossible to talk about all of the things that are out there. So sorry if I don't talk about your preferred technology. Thank you so much. So technology, what does technology mean? Actually, it can be what I call a platform framework. So basically, one technology that you can use to target the whole system, the business part and the UI part. Maybe you have some technology that you can use only for the UI part, some other technology that you can use only for business rules. And of course, to do all of that, you'll be using some kind of programming language. So this is what we're going to be talking about today. And in a more concrete way, what to expect. So these are the technologies that I'm going to be talking about today. So the Android SDK, iOS SDK, so the native, what we call native today, the official tools provided by Google and Apple to develop applications for their platform. Flutter React Native, the web in general with Ionic and so on. For the UI part, Jetpack Compose, SwiftUI, XML, UIKit, JSX, I'm going to be talking, I could put, I forgot to put CSS, we could put CSS here as well for the UI part. For business rules only, Kotlin Multiplatform. And then, of course, programming languages, Java, Kotlin, Objective-C, Swift, Dart, JavaScript. Then why I chose to talk about those technologies? This is a really good screen, so I guess you can see it well. This is why I'm using my iPad, so I can zoom in on the details. Here, yes, you can see well. This data is coming from JetBrains. no JetBrains that is behind, there is behind IntelliJ, Android Studio that is behind Kotlin. Those guys, those people created Kotlin as well, programming language. They do a survey every year. Here you can see this is coming from 2021, 30,000 people answered. And then I have another graphic that is coming from 2023, where 26,000 people answered. And then you can see the evolution of cross-platform frameworks that are targeting mobile and how they have evolved. Here we have data from 2019 to 2021, and you can see the progression of Flutter basically from 30% to 42%. React Native, there was a leader, now is 38% in 2021. Cordova, which is decreasing, Ionic decreasing, PhoneGap as well, but they were pretty popular like 5 or 6 years ago. So this has some consequences we're going to be seeing later. And of course, they have Kotlin Multiplatform here because since this is Kotlin, this is coming from JetBrains and they really believe in this technology. So it's showing up here. All of the other technologies I won't be talking about today because I don't have the time. And here you have actually, this is data coming from the last year. So this was from 2019 to 2021. This is 2022 and 2023. It's basically saying, yes, Flutter is still the leader. React Native had a little bit of decrease in 2022, but got back up to 35%. You can see Unity, that is decreasing a little bit, but still there. And then the other ones are decreasing. KMM, Kotlin Multiplatform, a little bit of decrease. And you can see the other ones as well. So again, this is coming from JetBrains. Always have in mind what is the source of the data that you have in. This one, for example, internet. Yes, this is coming from AppFigures. AppFigures, they do statistics of the technologies that applications present in the App Store use. So here you have, of course, we even if it's not that popular, it's still we don't always consider Unity as a non-native framework, but we cannot neglect the importance of games. So basically, for those who don't know, Unity is a game engine to build mobile games. So actually, as of January 2023, the most popular non-native framework was not React Native, was not Flutter, was not Ionic, it was actually Unity, which is actually kind of mind-blowing. And then you have this, which is kind of mind-blowing as well, Cordova. Cordova is in second place. Then we have React Native, Flutter, Ionic. And why Cordova is here? Because this graphic, what it shows, it's a snapshot. It's a photo that we have taken from the App Store in January 2023. The App Store is huge. There are so many apps that have been living there for so many years. And Cordova was pretty big, as I said, 7, 8 years ago. So a lot of apps are using those technologies because basically this is the oldest cross-platform framework. But what is really interesting to say is not that one, because we have a bunch of old apps that are using those technologies. What is really interesting is new apps. So this is showing new apps in 2020, 2021, and 2022. And then we have Ionic, Cordova, React Native, Unity, and Flutter. And basically you can see the increase of the popularity of Flutter, Unity getting a little bit second place there. And then React Native, again, Cordova and Ionic. So, and the third one, not as interesting, is only a comparison between Flutter and React Native month by month from January to July of 2023. And basically a little more Flutter new apps are published than React Native, but I thought it was interesting to share that as well. I'm sorry for the French here. This is I took from an article that was written in French, but the source is coming from Bitrise. Bitrise is a mobile CI solution, which is kind of popular. Who here? How many mobile developers are here today? And do you know about Bitrise, or do you use it? Do you use it? Yes. So I guess, I mean, the CI landscape is very diverse, but I guess we can consider Bitrise to be one of the leaders of, especially on the mobile world. And what is really interesting is that, can I take this cursor out? Because I have my own here. It can get confusing. What is really interesting that you can see here, they publish every year what are the builds, what is going on through the platform, what are the projects that are building, since this is a CI solution. So you can see here the evolutions of the technologies that I have been using in the platform since 2017 up to 2022. So this is, I think, the most interesting one, because this is the only graphic where I have native Kotlin and Swift projects that are here. And so orange and red here, you can see they were the vast majority in 2017, and then you can see it slowly decreases in percentage. And I'm going to be talking about that later. It is quite, I think, interesting. And you can see, of course, the increase of cross-platform frameworks in there are building on their platforms. So you can see here in orange and yellow Flutter and React Native. Of course, you can see here on this blue color here, basically the death of Xamarin, and then less and less Cordova and Ionic projects that are building. And it's really interesting because we just saw that Cordova was the second most popular framework present on the stores, but they're not active projects. They're just apps that are, of course, maybe there are some active projects, but it is not representative of what we are building today. This is representative of what we are building today. And then just to finish, I said to you that, yes, so what is going to happen? I don't know, in 5, 6, 7 years, native is going down and down and down. So one day it's going to disappear. I think we have to look at this graphic very carefully, because this is in percentage. And I want to guess, this is an hypothesis, but I think it's true that every year Bitrise is building more projects. Maybe this is an hypothesis again. Maybe the number, maybe I know 10,000. There were 10,000 more or less. This is a random number just to show you projects that were built in 2017, and there are still 10,000. But there are more projects overall that are being built. So this, maybe there's a little decrease, but it's not as high as what we see here. I hope I've been clear enough. Basically, there are more projects that are being built here, especially with the popularity of Flutter and React Native. And no, I don't think native development is going to be dead, never. There's always going to be a very good solution for building mobile applications. So let's take a look a little bit of history. I really enjoy talking about where we come from. Let's start in 2007, at the very beginning of the iPhone OS 1, because iOS, as we know today, as we call it today, it was only called iOS at the 4th version. So before we talked about iPhone OS 1, not only it didn't have the same name, but the very first iPhone, who here had the very, very first iPhone? No, you. I don't know if you remember, but there was no App Store. There was no App Store. There was no SDK. There were no iOS developers. There were no tools, because when Steve Jobs did, this is iPhone 1, but when he did the presentation of the very first iPhone, he encouraged developers to build web apps. He said the way that you build apps for the iPhone is by building web apps. Well, 1 year later, we launched the App Store with the SDK, and then we had also Android One with the Android SDK. But it was really interesting is that 1 year after that, we had Cordova that came to the game, because people were saying, okay, so we have all of these web technology knowledge. Let's try to make it work for mobile, basically. And it was really, really important. It still really is in some cases to be present at the stores. So it's not only by, of course, you can always build web apps by going to your favorite browser, but it was really important to be to say, oh, I have an app. So let's say people have this reflex to go to the store, look for your app, especially back then, nowadays as well. But I guess it's decreasing a little bit, I guess. But so people figure out a way to make web build native apps. When I say native apps, publishable apps that can APKs and IPAs that it can build, that it can put in the stores. Later then, it was called a PhoneGap, and now we talk about Capacitor, Ionic, and so on. But again, this was really early in the game, and I don't know people who have either developed or used apps that were using those technologies back then. They were slow. The developer experience was really, really bad. If I was doing the same talk in 2010 or 11, I would say, don't do this if mobile is important for your business, because this experience is going to be really, really bad for your users. But later, with other Ionic or React Native or other technologies that are being built with the web are good today, basically. So to go further, 2013, Facebook launched React. 2 years later, they took React and they say, oh, can we make it work for mobile? So they did the React Native. We have the launch of Ionic framework, and then 5 years later, Capacitor, which kind of the successor of Ionic, which is working well. We're going to see that on details after. 2017, we were talking about Flutter Alpha. The 1.0 got launched in 2018. And then on those latest years, we see the increase of not the increase, but the launch of new ways to declare UIs with native, with Swift UI, Jetpack Compose, and then Kotlin Multiplatform, which was in alpha since 2020, and stable since, it is December now, so not this month, last month. So this is really interesting to see the history of what was going on. What about programming languages? So, as we saw before, it was basically in 29 where we started, 28 where we started developing for mobile. What was the state of the programming languages in 28? So basically, if you did Android, you're writing your applications with Java 6. If you're doing iOS, it was Objective-C. If you're doing JavaScript for the web, the JavaScript, the ECMAScript specification was ES3. Then what we can say more about that, so we can see we can go further, and then we have the launch of Dart programming language, which is used for Flutter today in 2012. And only in 2014, we have the Java 8 release. Okay, cool, Java 8 release, but the support for Android development only came in 2017, 3 years later. What does this mean? Is that up until 2017, if you wanted to write a native Android application, you were writing Java 6 code. And then what happens just before the support, Kotlin gets launched. And Android developers say, oh, this is amazing. This is interoperable with the GVM. It's maybe this is going to work for Android. The support, as you can see, only arrives 1 year late, 1 year after the launch of Kotlin. But this was because the Android developers, maybe you can also say that if you were already a developer back then, that people really, really got excited about Kotlin, because again, when Kotlin got launched, they were writing Java 6 code. So they say, okay, let's make it work for Android. Then the Kotlin support got there 1 year later, and Only 2 years later, 2019, Google said, okay, this language is really cool. We are going to work with JetBrains, and Kotlin is going to be the recognized language to do Android apps, Android native. And then, but again, the Java language didn't stop there. So we got the Java 11 support, Java 11 release in 2018. The support only in 2021, the year of the release of Java 17. And then this year, we got the support of Java 17, the year of the release of Java 20. I'm going to be talking about Java later, but again, so you can see this, what was going on here. And only to finish here today, so since 2014 for iOS native, you write your code with Swift. And if you're using JavaScript, there's a high chance you're using ECMAScript 6. Okay, so this was for a little bit of perspective there, a little bit of history. I really enjoy talking about that stuff. When you target, when you talk about mobile solutions, I like to put them in 3 categories: either native, cross-platform, or the web. And then let's see how they work. So this is native. Native is the most, not common, but the most basic one, let's say. And again, these are the official SDKs provided by Google and by Apple. So you have your app here. If you're doing modern coding, Kotlin, Swift, Jetpack Compose, and Swift UI, you have first-party access to everything, to the system, to the sensors, to the widgets, to everything that they publish at day one, at the very first minute after the launch. You get access to the new SDK. So every year we will have a major release. And yeah, basically first-party access, very fast, very good, very good tooling. But the downside is those are 2 different stacks with 2 different kinds of set of skills. So in general, twice the number of people to make the same app. React Native, how does it work? So it relies on JavaScript because it's inspired by React. And then in order to have access to the platform widgets and so on, the services, you go through a bridge. This bridge translates or transpiles whatever you write here to official OEM widgets. So, for example, if you write here on the JavaScript code a button written for JavaScript for the web, on the runtime, the bridge, if it's running on an Android, it will call the real Android button, and if it's running on iPhone, it's going to be calling the real iOS button. This is what the React Native folks say. Oh, this is much better for the user because it is respecting the look and feel of the system. So yes, I guess we can say that. But the downside is that this is going on runtime. So maybe you can have some lags. So this is what Facebook really, Meta, really tries to optimize to be as fast as they can, because all of this is happening on the runtime as well as services, native services there. Ionic or any other framework that is using web views. Again, as a React Native, your code is being written in JavaScript. And the difference is that you're not using the official widgets. Basically, you're using a web view. It's a web view that you're displaying, the same one that you're using if you build a web app that is going to be used on the browser. And then similarly, you have a bridge to have access to all the services, native services. And then the biggest difference with Flutter. So this is the architecture for Flutter. The Flutter app and framework only relies on the canvas for the platform for displaying stuff. So basically, everything that you see on the screen, every pixel that is rendered on the screen, it is done by the framework. So here in green is either this is your app and this is the framework. Basically, all of the buttons, the labels, everything is done by Flutter. So this why they did like that was actually to provide a maximum performance on on the apps. And so they provide with the Flutter SDK, they provide a vast library of components that are either implementing material design. In general, this will recommend people to use material design for either Android, iOS, and even desktop apps, and then customize it to their needs. But if you really want to have like a calendar pick or a date picker, for iOS that really looks like the iOS widget, the Flutter team has actually copied pixel by pixel every main component of iOS, because of course this is not a cross-platform coming from Apple. So they took very high quality screenshots and they made the widgets look like the iOS ones, if you really want to use the iOS widgets. And then as for the bridge, for the other technologies, you have platform channels to have access to the services. And then, of course, you can build also web apps. This way you're targeting the browser. You're not building an app that can be published on the stores. So I'm not going to get into the detail, but you're doing web dev basically. So you're going to be using either your favorite JavaScript frameworks. Flutter works also for the web. Maybe you're building PWAs. And then this is not as hot from the press as it was at the beginning of the year, but one bad thing for the web apps on iOS was that push notifications, were not available for iOS. Basically, any browser didn't get support for push notifications, even if you have a Chrome or Firefox or other browser on iOS, because what you have to know is that every browser on iOS is Safari. Basically, Chrome only skin it to make it look like Chrome, but the engine is Safari. But this year, with Safari, the launch of Safari 16.4, we had the launch of Web Push. So this is really good for people who are building web apps. So this was an overview of the main solutions. So when you pick a solution, you're inserting yourself into an ecosystem and you gain stuff by doing that. So let's explore what you get by choosing something that is using either Java, Kotlin, Apple, the Flutter ecosystem, or JavaScript ecosystem. Let's explore them. As I said, Java, there's this always this lag for the Android support, but Java is a really important programming language for Android even today, because the AOSP, so the Android Open Source Project, if you take a look at that, as it name implies, it's open source. If you take a look at the system code for Android, there's basically Java code with some C and C++. So if you're interested in system development for Android, you need to know Java. And of course, the JVM. The JVM is big, very, very big in the world for server applications, for backend applications. So it is basically the same language. So important for Android system applications, and important overall because it's so popular for backend. Kotlin. Again, Kotlin was launched by JetBrains, and they are really ambitious about this technology. It's a really brilliant technology. I'm a big Kotlin fan. And they have thought of Kotlin as being as multi-platform as possible. So they have made these two initiatives that are called, the Kotlin Multiplatform. So basically here I show you the architecture where you can have a scheme, where you can have a shared module, which is written in Kotlin, and then you can integrate the same module on an Android app and an iOS app. So basically it is, you can share some business code by doing Kotlin Multiplatform. And then you have Compose. Compose, it is a JetBrains project, but they actually took the idea from Google, because Google, they redid the way we built UIs for Android with Jetpack Compose. and they made the choice to write it with Kotlin. So 100% of the library, Jetpack Compose, so the way we build UIs for Android, is written in Kotlin and is open source. And then JetBrains look at that, oh, 100% Kotlin, interesting. So, and again, they were really ambitious about the technologies. With Kotlin, they really wanted to make it work everywhere. So they say, oh, this is a really cool project. So let's work together. Basically, now JetBrains also works on Compose, but to make it available for all the other platforms. So for desktop, for iOS, and so on. And this is what we call the Compose Multiplatform world. And then this 1 month ago, more or less precisely, JetBrains just announced that Kotlin Multiplatform is now stable, especially for the main technologies there, because it's been in alpha for very long now. They say it's production ready, so you can try it on, and you can see even other platforms that are experimental or a best default there. And if you're writing Kotlin code, Kotlin has two kinds of compilation modes. Either you're doing Kotlin for the JVM, so this one's the not the most famous one, but maybe the one that can be the biggest, because it's targeting the JVM basically. You can also target it for the web with by doing Kotlin JS, and you can build with Kotlin native very low code, very low level code. Sorry, with Kotlin native. Kotlin for iOS is using Kotlin native, and then when JetBrains created Kotlin, they said, "Oh, we really need good adoption," so they made it interoperable with Java code. So Android devs here, maybe they already know that can actually mix on the same project. You can have Java and Kotlin code, because the bytecode is going to be looking the same and it's going to be compatible with the JVM, and you can have like the same graphic for Android as well. The two languages can coexist. The Apple ecosystem. So basically, when you pick Swift, I say, oh, I really like Swift. Swift is so cool. And I really want to be pushing that forward. And further, we have to know is that Swift is actually open source. You go github.com/Swift, something, /Apple/Swift, something like that. And they made the choice to be open source. It works on the server side as well. Swift is also a cross-platform framework. You can build server-side applications, backend applications. But of course, at the beginning, it was only working on Macs. I don't know who here has enough money to have huge servers with Mac computers. But it is also, well, as I said, it's cross-platform, so it can work on Linux as well. So you can build your backend applications with Swift, which is, again, if you're really passionate iOS developer and you wanted to get into a backend development, I guess this is for you. But for everyone else, well, will Swift be the first choice? I don't know. This is in general for people that really enjoy the Apple ecosystem. It is maybe something that can work for yourself, for your project, for your company, but it is very, very, very niche. And as Java is really important for Android development, Objective-C is still very present for iOS and macOS development. And this is only to show you all the different platforms that you can target when you do Apple code. macOS, tvOS, iOS, watchOS, and so on, and some of the libraries that you can use. Flutter. So Flutter for the front end, for apps. Flutter for apps. Basically, you have your app that is written in Flutter all the way up here, written in Flutter and with the Dart programming language. This app is using the Flutter framework, which is written in Dart as well. This framework is targeting the engine here, we're going lower, on the architecture that is written in C++, all the way down here, you have the hardware. So basically, Flutter apps, they compile to machine code, to low code, so that is targeting the GPU and the CPU. And in order to transform the code from the engine to the hardware, you have this level here that is specific for each platform, of course, as you can see, for iOS, Android, and so on. So this is what I really think is so interesting with Flutter, is that all of the architecture is the same, and only this is specific to each platform. But of course, the web is different because we're not targeting the hardware directly, we're targeting the browser. So we have some JavaScript stuff here, and we have also WebAssembly that is experimental with Flutter, as Kotlin has some WebAssembly that is experimental as well. When you write Flutter for the front end, so for apps, you're using Dart. A lot of people don't know, but as you can use Swift for the backend, you can also use Dart for the backend. There are some middleware that is available there. There is some things are available even with the GCP, the Google Cloud Platform, with Cloud Run. You have a VM where you can run your Dart code on the server. So yes, everything can work quite well there. Again, this is very niche as well, but since Flutter is getting more and more popular, maybe this can make sense for you. React Native, the ecosystem of React Native is basically you're inserting yourself in the React ecosystem and in the JavaScript ecosystem. React Native relies on the runtime that is running JavaScript. And I put some screenshots here coming from the documentation. I'm not going to get into detail, especially since this is not my specialty. But there has been some improvements made to the overall React Native architecture to make things work better. So a lot of things are experimental. So just if you want to try out React Native, be aware of that. But basically, all of the things are being inspired by the React components ecosystem. And then again, if you're doing React Native, you're doing JavaScript. JavaScript is the language for the web, so you can target apps that are using the browser. You can build JavaScript for the server with Node.js, Dino, wherever, desktop. For Electron, I didn't say, I just thought about, there's this even weirder thing that you can do with React Native is that you can build, React Native is not React. You can have a React project and a React Native project, React for the web and React Native for mobile. If you only have the React Native, you don't have the React app, you say, oh, what if I take the React Native project and I transform it to be desktop compatible without React, but by building React Native, I guess Blue Sky, you know, the Twitter alternative. They did that because they started with a React Native client that they have transformed into a desktop client, a web client, by using React Native, not React, which kind of blows my mind. I think it's so weird, but I guess it works. So this you can do as well. And this is basically, you have mobile here on the very beginning, and then you say, oh, if I choose native Android, what do I get? Okay, I can write some Kotlin code, so I can also do some Compose multi-platform if I have another client, desktop client, whatever, where I can have some shared code and so on. It is running on the JVM, so maybe I can have some kind of components that are going to be shared with backend and so on. So this is only basically this is a summary of the whole talk, and it's visible. Very cool. It's a big enough screen where you can see everything. So yeah, again, this is basically the summary of whole app, the whole talk. Sorry. So again, how do you choose? Okay, really cool. You have talked about a bunch of technologies. So how do we do? In theory, you don't have to pick one. This is even to get things even more complicated. You're not obliged to get married to one technology because almost all of those, they can actually work together. You can have modules that are written in some technology and some other modules that are written in other technology. This is only in theory. You can have a bunch of other options right here, but in theory, basically, you can mix everything. But in order to make a good choice, these are just some tips of some questions that you have to ask yourself or your company. The app, is it a new app? Is it an existing app? What is the complexity of the app? The features? Basically, is your app only going to be using native stuff, really hardcore native stuff? Telephony in general is a very, very no-go for web apps. If your app needs to basically make calls or stuff like that. So again, take a look at all of those features before making a decision for your project. The size of your team. If you're a team of one, well, come on, maybe you're really, really smart and you really, really want to learn native, but if there's only one person, there's a high chance that you're going to be picking a cross-platform technology. If there's an existing team, a big team of very, very high-skilled and very motivated native developers, I can talk about that by experience. They are really motivated by the ecosystem, either Apple or native Android. So I can go to them, take a look at Flutter, it's so cool. Can target both devices even more with desktop and web. If people don't want to do that, even if you can be twice as fast by doing cross-platform, by using a cross-platform solution, if the person doesn't want to do, they're going to be taking 10 times more because they just don't want to do it. So have that in mind. Of course, what is the budget? How much money do you have? I usually say as well, if you have unlimited budget, just go with native, but because of course, in general, it costs twice as expensive. But yes, I guess budget in general will take care of the company's budget. We don't spend as much as we can, as we want. And of course, the current tooling, if you have some current very, very good tooling, for example, for JavaScript, maybe you can take a look at React Native also. Other stuff. Yes, what are other folks doing in your company, web or backend? Can you reuse some of the skills that are outside of your current team in other teams? But as I always say, beware of the full stack promise. I think it's a good solution of being full stack, really targeting a lot of platforms at the same time, but you really need to have at least, in my opinion, one person at least that is really knowledgeable of iOS, of Android if you're doing mobile. Again, the market, the community, and the experience that the technology is providing. Just to finish real quick, as I said, a lot of times already, native, the official ones, always the most up to date. They allow fast innovation because you can try it from the very first minute. They're close to the OS. It's provided by Apple and Google with very good tools, but you have to have two teams. Cross-platform. You can have some kind of shared code base, but again, native knowledge I think is essential. Maybe you have to wait for some native features. And then at the end, cross-platform solutions, they are actually a dependency inside of a native shell. So you can get some unexpected quirks because they are basically a dependency in a native project. Some other aspects, React Native, you can take advantage of the JavaScript ecosystem. You can have code push, which is basically updating your JavaScript code that is already in production. Maybe if you have some bugs, you can do it without publishing a new version. Flutter, some highlights, excellent documentation, a lot of components, hot reload in order to have a really fast development. The equivalent of React Native code push is being currently done by Shorebird. So you're going to have the same feature there. And then for any web technology, you're going to be dependent on the browser, of course, on everything that it allows us to do, of the great functionalities, but also the bugs. if there's a bug present on prom or whatever, your app's going to bug basically, and then you can take advantage of the JavaScript ecosystem as well. And in order to make a choice, take your time, build POCs, ask your teams, your colleagues, what motivates them, really look how this technology works. There are a lot of blog posts that are out there that make comparisons, Flutter versus React Native versus native, which is the most performant or looks better or whatever. They always have a really huge bias, in my opinion, and it's almost impossible to make a 100% fair comparison. But my personal conviction is that tomorrow's mobile project can be written in whatever technology, but at least some kind of code is going to be shared with all of the platforms, so Android and iOS. Thank you very much. Follow me on Twitter, X, wherever you can look for my for me on LinkedIn. I accept everyone if you want to. If you have, I don't know if you have time for questions, because I was really in my head. I have 50 in my head, so yeah. Yes. No questions. This is really loud and really close. I'll be here all day if you want to talk or offline as well. Thank you.